today we're really getting into the Qwen3 technical report that just came out.
Yeah, and this isn't just another AI announcement, is it?
No, exactly. We want to look under the hood, focus on the real academic innovation here, the nuts and bolts behind this new model.
Precisely. Our mission today is to understand those key contributions, the innovations in Qwen3 that are genuinely pushing things forward in large language models.
We want you, the listener, to get a handle on the why and the how behind these advancements.
And we're drawing directly from the Qwen3 technical report itself, plus looking at the academic papers and benchmarks they reference.
Okay, so let's jump right in. One of the biggest things seems to be this idea of unified thinking and non-thinking modes in one model.
Yes, that's a core innovation. Academically, it's quite novel.
How so? What's different from before?
Well, think about it. Usually you might have needed, say, one model that's quick for simple answers, and a totally separate, maybe bigger model for complex reasoning.
Right.
Qwen3 integrates these. It has a thinking mode for the deep, multi-step stuff, where it might even generate intermediate thoughts like we do.
Okay.
And then the non-thinking mode for faster, context-based responses when you don't need all that heavy lifting.
So the report says this eliminates the need to switch between different models. That sounds like more than just having two parts, right? It sounds architectural.
Absolutely. The academic weight is in that unified framework. It's not just bolting two things together. Before Qwen3, getting both speed and depth often meant juggling different specialized models. Qwen3 aims for fluidity within one architecture.
So it can adapt its processing style based on the query.
Exactly. Or even based on chat templates. It allows for dynamic mode switching.
Okay, and then there's this concept of a thinking budget. What's that about? Sounds like you can control how hard it thinks.
Yeah, it's a really fascinating outcome of what they call thinking mode fusion. It's not just a feature they added on top.
Right.
Because the model learns both modes during training, it naturally develops this kind of spectrum of reasoning ability.
Ah, okay.
So the thinking budget lets you manage the computational effort during inference. You can sort of dial the reasoning effort up or down.
Balancing speed and accuracy, essentially.
Precisely. And the really cool part, academically speaking, is that this emerges from the training. The report notes, let me find the quote, here. Once the model learns to respond in both non-thinking and thinking modes, it naturally develops the ability to handle intermediate cases generating responses based on incomplete thinking.
Right.
This capability lays the foundation for implementing budget control. So it's an inherent property, not just a switch they added later.
That's a key insight. It arises from the training. Okay, let's shift gears a bit. Multilingual support. It jumped from 29 languages to 119.
A huge leap, from 29 in Qwen 2.5 to 119 languages and dialects.
Wow. What are the academic implications of that kind of breadth?
It's a major step for cross-lingual AI. Think about global accessibility, understanding nuance across cultures. Benchmarks like Include, which tests regional knowledge in, I think, 44 languages, show how complex this is. Qwen3's reach suggests a potential for much deeper cross-lingual understanding and interaction.
And the data behind this, the report mentions 36 trillion tokens.
Yeah, the scale of the pre-training data is immense, curated for diversity across languages and domains.
How does that sheer volume help achieve better cross-lingual abilities? Is it just more examples?
It's more than just examples. That scale lets the model learn really subtle statistical connections between languages beyond simple translation. It helps grasp underlying meanings and generate appropriate responses across that huge linguistic range.
Okay, let's get into how they actually built this thing. The pre-training strategy sounds quite deliberate. 3 stages.
Yeah, it's a carefully designed progression. Stage 1 is foundational. 30 trillion tokens of general knowledge, just building a broad base.
Right.
Stage 2 gets more specific. They inject knowledge-intensive data, focusing on STEM and coding, sharpening those skills.
Makes sense.
And stage 3 is about context length, training on long context data, starting at 32K tokens, then pushing to 128K for most models, so it can handle much longer inputs.
Very structured. Did they use any novel ways to get all this data, especially the specialized stuff?
They did some clever techniques for data expansion. For instance, they used their vision language model, Qwen 2.5 VL,
Oh, interesting.
to extract text from loads of PDF documents, a smart way to boost their text corpus.
Yeah.
They also generated synthetic data using their own specialized models, like Qwen 2.5 Math and Qwen 2.5 Coder, to create targeted examples for those domains.
Kind of like teaching itself specific skills.
Exactly, leveraging existing strengths to build new ones.
The report also talks about a multilingual data annotation system and optimizing the data mix at the instance level, not just domain level. That sounds advanced.
It is. They went beyond just saying this data is math, this is literature. They developed a system to add fine-grained labels like educational values, specific subjects, even safety aspects to individual data points.
Okay.
This allowed them to optimize the training data mix much more precisely based on experiments with smaller proxy models. It's a step up from older methods that just mixed broad domains, more scientific data curation.
And they didn't just throw data at it, they studied the training process itself, developing scaling laws.
Right, they look systematically at how things like architecture choice dense versus mixture of experts interact with the data at each stage and the best hyperparameters like learning rates.
Uh-huh.
This let them derive scaling laws to predict optimal settings for different Qwen3 models. Less trial and error, more principled training, which is crucial when you're dealing with models this big.
Makes sense. So all this effort in pre-training, how does it translate to performance? The benchmarking section seems extensive.
Incredibly expensive. They tested it across a huge range of benchmarks. General knowledge like MMLU and BBH, C-eval,
Right.
math and STEM like GPQA, GSM-AK, math, coding like eval plus, multi-PLA, and of course multilingual tasks, MGSM, MMLU, include, and TNM, the list goes on.
A real gauntlet.
Definitely. Gives a pretty comprehensive view of its capabilities.
And the results. The headline seems to be state-of-the-art, even comparing favorably to bigger proprietary models.
That's the main takeaway. Qwen3 often performs at or near the top, sometimes beating models like GPT-4o or DeepSeek v3, even when Qwen3 has fewer parameters.
That's a big deal for efficiency.
Absolutely. For example, the Qwen3 235B A22B model scored 85.7 on the AME math benchmark. That's very strong. Wow. And it's not just the big ones. They highlight how well their smaller models do, suggesting good knowledge transfer from the flagships, like Qwen3 32B base apparently outperforms the older, much larger Qwen 2.5 72B base on most benchmarks.
So the training improvements benefit the whole family. What about the thinking mode evaluation? Did they show it scales with that budget?
They did. The report includes results, specifically Figure 2, showing performance on reasoning tasks improving as the thinking budget increases.
Okay.
It scales nicely on math, coding, STEM tasks. It directly validates that the thinking mode and the budget control actually boost reasoning when you give it more resources.
And head-to-head against other open-source models, like Llama 4 or DeepSeek v3.
Very strong comparisons there, too. The Qwen3 235B A22B model, for instance, beat DeepSeek v3 base on 14 out of 15 benchmarks they showed, despite having fewer parameters overall.
Fewer parameters, but better performance.
In many cases, yes. And the Qwen332B base also showed big gains over Llama 4 Scout base. So it's really competitive in the open source space, often punching above its weight in terms of parameter count.
Okay, so pre-training is solid, evaluation looks great. What about post-training? Any academic innovations there, especially around developing those thinking, non-thinking modes?
Yes, the post-training is also quite sophisticated, especially for the flagship models. They use a 4-stage process.
4 stages.
Yeah. The first 2 stages focus specifically on cultivating and improving the thinking abilities, developing that deeper reasoning.
Right.
Then the next 2 stages work on integrating and refining the non-thinking side, the faster responses. So they deliberately tune each aspect before bringing them fully together.
Interesting. And for the smaller models, they use strong to weak distillation. What's the academic angle there?
That's a knowledge transfer method. You take a powerful teacher model, like one of the big Qwen3s.
Okay.
And use it to train a smaller student model. Instead of putting the small model through the whole 4-stage process, you distill the knowledge, including that crucial mode switching ability from the teacher.
More efficient.
Much more efficient computationally. The student learns to mimic the teacher's outputs or internal states. It's a way to get high-performing smaller models without the full training cost, which is academically valuable.
Makes sense. They also mention a careful process for filtering reasoning data for fine-tuning.
Crucial step. Getting good reasoning examples is hard. They used a 2-phase filter. First, use a strong model like Qwen 2.572B instruct to filter the queries, make sure they actually require reasoning.
Right, not just simple questions.
Exactly. Then generate multiple answers using their reasoning model, QWQ32B, and filter those responses, rigorously checking for correctness, avoiding repetition, using human review too, meticulous curation.
Sounds intensive. Okay, nearly there. Long context up to 128K tokens. How did they manage that?
Yeah, 128K is impressive. They evaluated it using the ruler benchmark for long context tasks.
And the technique?
They used yarn. It's a method that helps models extrapolate to longer context lengths than they were strictly trained on.
Okay.
And interestingly, they still apply the thinking budget concept, even for these really long inputs in thinking mode, which helps manage the compute cost.
Smart. It really feels like a comprehensive effort, top to bottom. And the open source release under Apache 2.0 is important too, right?
Absolutely vital. Making these models available allows everyone in the research community to reproduce results, build on the work, and push the field forward collaboratively.
So, if we were to summarize the key academic takeaways, the big contributions from this Qwen3 report.
I'd say there are a few major ones. First, that novel integration of thinking and non-thinking modes in a unified framework, plus the emergent thinking budget. That's a fresh architectural idea.
Okay.
Second, the massive leap in multilingual support to 119 languages, underpinned by that huge, carefully curated 36 trillion token dataset that really advances cross-lingual AI.
Right.
And third, the state-of-the-art performance shown across so many diverse benchmarks, achieved through really sophisticated and innovative training, data handling, and post-training methods. The rigor is impressive.
And the open source aspect empowers the whole community.
Exactly. It gives researchers the tools to dig deeper, verify, and innovate further.
So here's something to think about. How might this blending of fast and slow reasoning in one model change how we design AI going forward? Could it blur the lines between reactive systems and more, well, deliberate ones?
It's a fascinating question.
And what new doors might open with truly powerful multilingual models that understand context so well across so many languages? We definitely encourage you to check out the Qwen3 technical report itself and the papers it cites for a much deeper view.
Definitely worth exploring.
Thanks for joining us on this deep dive.